Find the area between the curves, curve number 1, curve number 2. All right, so this is what I'm going to do. I'm just going to make believe that I know exactly what these curves look like. So that's a parabola. Parabolas usually look like U. This is a parabola. Parabolas usually look like U. Obviously, these aren't perfect. Okay, but what I also know is that x equals 1 when graphed is a vertical line. Okay, and x equals 3 when graphed is a vertical line. And I care about this shading right here in between these guys. So when you find the area of a curve in general, you take the integral. Now, if you have two curves, you're going to subtract one integral, or one equation minus another equation, integrate that, and then you have the area that you want. Now, the fun part about this is we know what my limits are. My limits are 1 and 3. So my job is to find this mess right here. So let me erase all of this, hit the reset button. Let's go for it. Now I'm going to write out this really big integral, okay, where I have, and you know what, let me put this whole thing in brackets, otherwise it's technically not, sound. 2x squared minus 8x plus 10 minus x squared over 2 minus 2x minus 1, close it, bracket it, dx. Now, if you're wondering, well, which equation is definitely the above one? My job is to find an area. It doesn't really matter which equation you put first, as long as you use common sense. If I do all of this and I get negative 50, that means I did it upside down, and I just changed my answer to positive 50 because you can't have negative 50 as an area. I'm not saying that that's what's going to happen here, but, we'll see. Now, what I do have going on in here, oh, by the way, I can't forget that I have limits, and my limits are 3 and 1. Ooh, 3 and 1. The Trinity. So I have, let me see, this is going to be a mess. Let's write this all out, although I really don't need those parentheses anymore because I'm going to try to simplify parentheses. So I've got 2x squared minus 8x plus 10, distribute this negative, and let me write it out as a better looking fraction. So that would be 1/2 x squared plus 2x plus 1, close the bracket, dx. I think I should be able to squeeze it in here. 3, 1. All right, 2x minus half an x is 3/2 x squared. 3/2 x squared, can't forget that. I have negative 8x, positive 2x, negative 6x. 10 plus 1 is 11, last time I checked, dx. Okay, so let's take the integral of each one. Let's take the integral of each one. I get 3/2, okay, times 1 over 2 plus 1, which is 3. How nice. X to the 2 plus 1, which is 3. Okay, let me put a huge brackets here. Minus 6, 1 over 1 plus 1, which is 2. X to the 1 plus 1, which is 2. Plus 11, and you just attach an x. My limits of integration are going to be 3 and 1. So we get 3/2 times 1/3 is going to be 1/2 x cubed minus 3 x squared plus 11x between 3 and 1. All right, now let's use the fundamental theorem of calculus, which has me writing this whole monster out, plugging in 3, minus sign, write this whole monster out, plugging in 1. So let's do it. So I have 1/2 times x to the 3rd, so 3 to the 3rd, this is going to be awful, minus 3 times 3 to the second power plus 11 times 3 minus, okay, the exact same thing, but plug in 1 half, 1 to the third, I can handle that one, minus 3 times 1 squared plus 11 times 1. All right, let's see what I can do in my head. Let's see what I can do in my head. I'm actually going to step to the side and just do all the math on a calculator and then come right back and tell you what the answer is. It's 11. All right, I ran out of room, so if I wanted to, I could have been like, all right, well, 27 over 2 minus 27 plus 33, and then have a big mess. But according to Mr. Calculator, I get 11, and I'm going to trust Mr. Calculator. Mr. Calculator, I'm sorry, or Ms. Calculator is pretty smart. So that's the area between curves. So whatever that black space was, that was right here, it's 11. And again, if I got negative 11, that's just because I had these upside down. I had the wrong order in which I had my lines. Not the end of the world. Just make it positive because you can't have a negative area. All right. Fun.